and we were wondering how fast China is growing, and we just were surprised that there are no level 3 or level 4 cars admitted to the streets there. And well, I said, yeah, I think I know why this is the case, and there is some basic knowledge, let's say, behind it. And there's, I say it's like an iceberg theory. So there is a software that everyone thinks, yes, you can make it safe. You have tests and you have documents, and then it will be safe. Yeah. But the software is using libraries, it's built using tools, and also those have to be safe. And otherwise, the software won't be safe if the tools are buggy or libraries are not. And this is somehow something where also we are at VALIDAS are working in this field, and therefore I think it's very important for understanding why some things take longer. And today I try to put together with Felix an agenda to explain more things, basic things about certification. So Bob will start with giving us an overview of a framework of what all needs to be done there. And then we will dig deeper into this. But let me come with the organizational thing. So we will have a break, and we'll go into the indoor room on the 0 level, and on the entrance hall we can have some drinks in 20 minutes. But if we move 200 people to the 5th or 6th floor, where we'll have some barbecued things later, it won't take a half an hour, so it is not doable, and therefore we decided, okay, let's first do the interesting talks and then go up and have party there. So we will have. We wanted to have a barbecue there, but barbecue for 200 people is so big, so we didn't get it up. And we will have a lot of barbecued, nice, cool things, and we will have some beer to drink and wine, and everything will be good. So this will be all then after the talks. So that's definitely being good. And of course, we have a rooftop. We can go outside and see there and sit there. It's a bit cold today, but let's see if someone wants to smoke there or whatever, then please feel free. So that will be the organizational aspects here. And now I don't talk about VALIDAS today. So you can explore about what VALIDAS is doing. There are some posters here around. There are many people you can ask, and you can just explore what we are doing. And I think the more important thing is that we have good speakers and focus on them. And therefore, let me like to welcome Bob and give his first talk here. Thank you.
All right. Am I on with the matter? Yeah, sure. Yeah. That's the presenter? Yeah. All right.
By the way, the talks will be recorded for those we may record, and who we may not all the talks, but some of them will be recorded. So we're using the Teams facility for that, and we'll afterwards publish those that we may publish. So just in case you have a question or whatever, feel free to use the mic, and then, yeah, we'll do this.
All right. Thanks a lot. What a lovely crowd. So late in the evening, talking about product conformity. Thank you for letting me be first here, because otherwise people will fall asleep. It's a dry topic, I know, but I try to show a little bit what can be done today in a digital way. So I'm not going to talk specifically on how to interpret regulations or which regulations you need to abide to, because I think that you already know all these things. I'm Bob Bereczki, one of the co-founders of Certivity. We are a startup, started 2.5 years ago in the domain of digital product compliance. Let's kick it off. All right. So when we think about engineering, I'm not talking only about ADAS or automated driving. I'm talking especially in a generic sense in the automotive industry. You know that we're thinking about people coding software or developing parts, ECUs, also hardware, of course. Many parts of the car is actually heavily regulated. And what is really true is that there are in excess of 5,000 regulations out there worldwide, governing the many parts and many systems and components of the car that need to be brought into conformity. So those regulations, those standards, those norms are basically mandatory documents that one you developers have to take into consideration. And it's not only the 5,000 regulations, because mostly for a part or for a system or a component that you are designing, there are not so many regulations, perhaps. A lot of technical requirements inside those regulations. But not only that, you have to take into considerations that a regulation or a standard is a living document, which means that it gets amended as we speak, basically. So a couple of times a year, sometimes just a couple of paragraphs, sometimes the whole regulation is being reverted, basically, and then it says something else. And your product development cycle might be, I don't know, 40 to 48 months if you're looking for a brand new system on a brand new type of the vehicle. And then, well, you have to keep pace with all these requirements. Now, today, and I don't know how you do this, but in the companies I was working for, we have done this mostly manually. I mean, with Excel, because Excel is a very easy to handle format. It's easily, given to the other stakeholders that you're talking about, to the legal folks, to the regulatory folks, to the certification guys, to somebody who can make sense of it, to see if what you're trying to do and how you're understanding the regulation is the right way to do. So, and then everything ideally goes into the system engineering tools, right? Whatever you'll be using, IBM Doors or Polarion or JAMA Connect or Enovia or whatever it is, basically. Because this is where you actually get your SIS1 requirements, your stakeholder requirements. All right. Now, what is the core of the problem? Now, on the left-hand side, you see here that you have regulations as documents. Mostly they are Word documents or PDFs, or they are, I don't know, just websites, basically, where the regulatory bodies basically promulgate their requirements and their laws. And what you have to do as a system or component developer is to find those regulations worldwide, if you're developing in a worldwide scenario, and to go through this tediously to these regulations and find actually the applicable set of requirements that govern your system. Not everything is applicable in one regulatory document, depending of what you are actually developing. And then you have to understand and extract those requirements, discuss maybe with peers in your organization or with external partners, how to understand and how to interpret all these legal requirements, because while they are technically written with formulas, with tables, and in a technical sense, they still have a legal touch, because we're talking about mandatory regulations here, that you have to be in fulfillment with. And after you align with your peers, you basically enter your V model, probably, where you have the stakeholder requirements, and you then go on and develop. You might have, of course, also other requirements internally from customers, and so on and so forth. But the legal requirements are paramount, because if you're not in compliance with them, then you're not going to get a certificate, or you're not legally on the roads, and not your client, or if you are an OEM, then you're not legally on the roads. So the problem is that all these documents, all these regulations are prone to change, and they do change very, very often. A couple of times per year, this can happen. Especially, you're not in the emissions business, so that's fine. You have smaller regulation, let's say around 100 pages, maybe in the PDFs. But if you were in emissions, you are faced with thousands of PDF pages full with requirements. That's the emission stuff. I'm gonna spare you the details here. All right, so you have to be looping around your V cycle, basically, and go back to the SIS1 requirements, amend them, and then change your development cycles. Not the development cycles, but change a bit your development in order to be compliant with those requirements. All right, so going away from Excel and going away from the PDFs. Hands up who loves to read regulations in a PDF. Okay, we have one guy, another one there. Okay, congratulations, mate, you can leave. All right, so just joking. The foundation that we lay out as Certivity is to digitize those documents, paragraph by paragraph, whether there are regulations, norms or standards, or they are just custom-specific documents like Lastenhefte, so requirement decks, basically, that at one point in time you want to track in your system engineering tools. So how do we do that? Now, we have created, of course, a customer platform for this, where we pre-process those regulations and bring them in the system such that you can consume them. Now, what sounds a little bit like a marketing session, I don't want to appear like I'm selling you anything. I just want to show you a bit the complexity behind that. Now, in here I have an example of the AEBS regulation, so UN Regulation 152. That's applicable in the European Union and also in other states like Japan, for example. And we're looking at paragraph 5211. We're extracting this collision warning and digitize it. So it's not copy paste. We have a pipeline for that. And everyone who does this kind of things needs a pipeline for that, because doing this manually, it's very error prone. Now, what you need first is a trace back to the original and legally binding document, because that lies at the heart. You want to have to get a traceability from your system engineering tools to somewhere to know where does this requirement is coming from. But you can extract a lot of things from here. The identifier, and by the identifier, you already know that the parent of this paragraph is 521. We need that because we want to hierarchical decompose the whole regulation, such as when you export this to your system engineering tool, you do not have a flat list of paragraphs, but they are somehow ordered logically in a hierarchical decomposition manner. We also know that when you go through the regulation, there are siblings to these paragraphs. There are linked elements. So that's a problem with the regulation. I mean, they don't tell you in a paragraph, hey, do this or do that. Yeah? They tell you, do something like this. By the way, look also in the other paragraphs and look at them together. So resolving these paragraphs and giving the context to it is very, very important for the understanding on how to extract your own functional requirements, basically. Of course, it's important to know the version that you're looking at, because again, the regulation is being versioned and is amended. And then also we can categorize it, and you can say, hey, that's a requirement, and it's also a test requirement, because that's the problem with regulations. The regulatory body wouldn't care less about system engineering. Yeah, they tell you, hey, you know, the performance of the system should be like this, and by the way, this is how you test it in one paragraph. You have to segment this a little bit. And we can also annotate what kind of requirement types there are. So in this paragraph, there is something about the performance of the system, and it's also about the human-machine interface, because it's called also collision warning. And there it says, hey, if something is happening, then show it to the driver in a way. And of course, we also can determine what kind of vehicle type we're looking at. So M1, N1, the whole regulation is written for M1 and N1, so passenger cars and light commercial vehicles. But there could be paragraphs that are looking only on passenger cars, and there could be only paragraphs that are looking only on light commercial vehicles. So if it happens that you are only looking at a passenger car, then you can skip the other paragraphs because they are of no importance to you. And of course, there are a lot of, often, not in this case, but there are a lot of links to other standards or norms or any other regulations, basically, or paragraphs in other regulations. So you have to read all of this together somehow. And if you consume PDFs, and you're going to have a lot of PDFs open at the same time, basically, and look into that and make sure that you have the right versions, basically, in between the PDFs. Whole thing. If you thought that the regulation is being amended, or the regulatory body, when they make an amendment to the existing regulation, gives you the whole regulation from top to bottom, you are wrong. They tell you only what changes. So this is the paragraph that is existing, and then they produce a document. And this is the worldwide phenomenon, because this is how laws basically work in international forum. They tell you, oh, by the way, amend paragraph 5211, looking at the last version, and amend it as follows. And then you have to advance this version, create a new version, put in the changes, and create again a top to bottom regulation. This is called consolidation. Then there's no use to it if you don't create a relationship between the paragraphs. For each paragraph has a trace, has a lifetime history, basically. It's a regulatory graph. So in one version, the paragraph is version A. In the next version, this paragraph doesn't change, but in the third version, it changes. So you have to incorporate those changes and create a trace of what actually changes. And this is the art of consolidation. And sometimes the consolidations are quite complex, and regulatory bodies also make mistakes while doing this. Yeah, I meant paragraph 5211, only you see there is no paragraph 5211. Oh, it's an Annex 5. All right, okay, now I got it. So a little bit of sensitivity is required for this task. Okay, if you buy into this game that a document, a regulatory document or a standard can be decomposed hierarchically in logical parts, and logical parts are in this case not an atomic part that you're looking at the requirement, but the paragraph is the atomic part. What can you do with that? With all these versions? Now, you can do a lot of things. If you look at law as data, you can run basically all these paragraphs through an AI engine and identify requirements. What is a requirement? A regulation doesn't only contain requirements. It contains definitions. It contains a lot of certification procedures and things like that, due dates, transitional provisions, when you have to apply it, when it's too late to apply it. All right, you can build digital regulatory twins, basically. You start from one point in time and then let the regulation advance and get basically the newest updates on paragraph level in your system, ultimately in your system engineering tools. How do you collaborate internally? Go away from the Excels, because every department has a different type of Excel that fits their purposes. How can you basically distribute that information on how to understand the paragraph inside the entire company? Now, this is also possible with collaboration and interpretation workflows. Needless to say, you need the integration in the existing engineering tools, because this is how or where developers ideally should be working with. And of course, be always up to date of any changes, because the later you get aware of a regulatory change, the more it costs, basically. Okay, what I just said is, let's apply it a little bit. Unified view. So if you want to read the regulation top to bottom, all right, good luck. You might get bored a little bit after a couple of pages, because you see, well, where are the requirements? Where do I find them, basically? Now, you can also ask, what are the requirements? What are the test requirements? And what are the audit and process requirements that are needed to take into consideration in order to get a certificate for that? And most importantly, to be compliant with the regulation. So there are categorizations available that basically pinpoint what this paragraph is telling you. It's a definition, it's a certification procedure, or whatever it is. You can compare, because you have the regulatory trace between every virtual version and every amendment of the law. You can compare any regulation, any version of that regulation. Forget beyond compare, because beyond compare, I mean, there are annexes that are moved to chapters, and chapters move to annexes. So beyond compare will not be of help here. So you need the regulatory trace. You need to know what happened to that paragraph in that instant. And you can visualize the changes, basically. Interpretation, you can, I mean, in my former work, I had a lot of questions from people, one designing a brake system for the A3, Audi A3, and the other one for the Audi A8. They were in the same department, but different hardware, different things, basically, they were looking at. And they had the same questions. And I always had to send the same interpretation, because the law doesn't really care about what you're developing. They say, oh, it's a brake for whatever car. That's fine. And this is how you can basically publish in your corporation the interpretations or comments to a certain paragraph. And when the paragraph changes, you want to know, oh, do I have to amend that interpretation or not, because it's published in the entire corporation? All right. And that can be also exported basically to system engineering tools. As I mentioned before, it's paramount that you can export the regulation to a target system. And the thing is, many tools today, like Polarion and also JAMA, for example, you can import an Excel initially. But the problem is, if you have changes, if you have another PDF that says, oh, paragraph 5211 amend to read, delete paragraph 3, insert Annex 5, then these tools are not doing anything. They're just importing on top of your requirement something. It doesn't get you suspected links, or it doesn't get you any heads-on of what is changing. Now, the truth lies in the data, how the data is amended, and when you re-import something, you just want to see the changes. You do not want to have anything else changed, only the regulatory requirements that indeed are changing. Not the entire regulation is changing in case of an amendment. All right, digital regulatory twins. So now if you are very specific on, segment every version of the regulation in chunks, basically in paragraphs. What you can do is say, oh, I'm doing an AEB. And the AEB is regulated in the European Union, it's regulated in China, it's regulated in the United States. Yeah, and also in other territories. Now, ideally, you want to provide one version of that system and not 3 different types. Now, what you can do is put all the applicable regulations in one place. And from that point in time, you start tracking any changes, basically. And you also can write your interpretations and requirements to every paragraph. So to see that a little bit in action is, sure, you still have to read to the regulation. I mean, that nobody can take away from you because you need to be compliant as a developer. However, the digital regulatory twins are set out to give the opportunity to you to say that paragraph is applicable to what I'm developing, and that paragraph is not applicable to that. So you have the choice to set your applicability matrix, and then you can export all of that to your system engineering tools. Of course, you can write also the first level derivation of requirements, because again, a paragraph can be half a page basically. And if you want to go a little bit atomic with your requirements, you need to segment that. Yeah, one paragraph gives rises maybe to 3 functional or non-functional requirements. And that you can link basically in here. We're not trying to replicate any of the system engineering tools. What we're trying to do, in case of an update, to show exactly what has been updated, what exactly is affecting you based on your applicability matrix. And if there is a new paragraph, to ask you, is this new? Think about it. Is it applicable to you? Yes or no? You can create as many custom fields basically in this regulatory twin that you can also export into your system engineering tools, depending on the platform, on the template that you're basically using in your system engineering tools. Every corporation does it a bit differently, so the flexibility is basically there. And the digital regulatory twin is intended. It's not only for regulations, for any kind of documents that are prone to change and have a structure. Yeah, it's not a child book, but it's something that has a hierarchical decomposition. And then you can basically work with that. And whenever something changes and you might have some first functional requirements derived, and the platform will tell you, the digital regulatory twin will tell you, hey, there is some change in there. And have a look if those changes are affecting what you have derived or all the custom defined fields that you have basically created and put information in there. So this is what can be done. Now, I know that I'm a little bit advanced in time. What time is it? Jesus Christ, 20 seconds. So shall we remain in silence or no, we don't? Yeah, what we basically provide are digitized regulations, not only for ADAS and automated driving, also traffic laws, basically. Yeah, but it's on the entire vehicle. Yeah, we're not only looking at ADAS and AD, even if we're coming from that area. All the amendments that we are consolidating after 2 weeks after they are promulgated, you can compare and analyze the regulations to get insight of what you need to be doing, basically, in order to be or remain compliant. You can collaborate and interpret and gather a knowledge base in your company regarding the regulatory work. And sure, you have, of course, the heads up of the updates that you're getting. You get automatically notified. You create your, I know you're impatient. Now give me just 10 seconds. You have the regulatory twins, basically, that you can advance, and they tell you, basically, what changes are affecting you and which are not affecting you. And you can create this kind of individual projects and export them to the system engineering tools. And that's it, Oscar.
Okay, thank you very much.
Thanks, guys, for bearing with me.
So how nice is the world if you have only ISO 262 and maybe IEC 61548 compared to this huge amount of standards? So thank you very much for this. Is there a quick question for Bob?
Exactly. Please remain on stage in case there are questions. So, and I don't know if there are any questions from the chat. I think that was a possibility as well, but I think there's the first.
No.
I'll bring the microphone to. Oh, okay. Sorry? But you have a question? That's the question. The microphone to.
Yeah, sure. Yeah.
You still have to answer, right? Anyway. Other questions? Here's one.
Just a question. You say that you could then make, let's say, the requirement being generated. Then is there a guarantee that it covers everything, or like it can be that if you use LLMs or whatever, then you just missed one of these points. So how do you deal with that?
What you think? It's fit for purpose. We are working now heavily. We have a machine learning team inside our company, and we are looking basically at an AI team that we're looking at deriving functional and non-functional, this categorization basically according to different schemes like EAR, SOPHIST, and so on. That's never a guarantee, of course, but it's an indication for you to review. I mean, we're not gonna build the system for you. We're not gonna, after Certivity you press OK, and then the software is developing by itself. Of course not, but it's a way forward, a help to do that. But this is only possible if you segment the paragraphs and you have the latest versions.
Maybe you have worsened your situations, or maybe the question was, what if? How can you qualify the tool that it does not lose a requirement? And now, no, he's not. But maybe then you say, okay, we're using AI to generative AI. Then the question gets even mean. Yeah, what if, and so on. But I'm sure you're working on that. So
it's domain-specific language.
I think we have a lot of time to discuss, and you will remain here with us, and that's definitely great. So then let's thank Bob again. Now let's hand over to Henrik. So when we know each other very long, but some month ago I had a workshop with him where he did a 2 hours presentation. I was like, wow, I've never seen something impressive like this. And then I invited him to present this regulatory framework, and we'll go how to make AI safe in different levels and layers. So yeah. I think he will present this. And now it's very, I'm proud to have him here. And let's start the presentation here. Well, while they are working, I'd like to welcome very much our remote guests. So while you can have a beer and something to eat here, the remote guests cannot. So they are really here only due to the theory. And I think we should have a special thanks to them because that's more brave than we are here. And that's really nice to have. They are from US, from Asia, or whatever. So there are some colleagues very interested in these topics. So let's thank them. And yeah, let's start you getting started. Is the mic working?
I check. Is it working? Can you hear me?
Yeah. Okay, so then thank you.
So thanks, Oscar, for the nice introduction. And thanks, Bogdan, where are you, for the presentation. I should have known you 1 year ago, where I actually did this for steer-by-wire system. So we have to talk to improve. So I'm a little bit captured behind my... I rebuild the stuff here. Okay, so we have another number here. And sorry to be a little bit more formal, but I'm for standardization. And somehow the title creeped a little bit, so I'm on standardization. But I'm also on research. I was part of Fotios, and I'm also on the practical side. So I'm one of these consultants that help you doing things the right way, doing ASPICE, doing functional safety. And maybe one of my famous works you have already read. It's entitled ISO 26262. I was part of the first team doing it, so I know a little bit of this. And I was doing functional safety and AI for a long time. And then I thought, okay, we need to combine this. So how to do it safe in systems engineering? So now again a number. All these numbers are meaningless. Ours are not. So 28 is, I couldn't help it, 28. And this was the area we were working in the VDE, DKE, in the working group. But of course, all of you, or at least 90% know 42, right? Hitchhiker's Guide Through the Galaxy, it's the answer to all questions, or standing for AI, you know, the subcommittee in the ISO 42, right? And what again is 6.1? Any idea? 61508. What was that again? So this was the one we were looking at when we designed the standard. So we will talk about functional safety, and even more, we call it trustworthiness, which is a meta term including safety, also cybersecurity and other stuff. So I don't want to bore you. We know AI is on its way, and we are all struggling with the question how, not if. And famous guys from Bosch, from others told us there will be scarcely no product without AI in maybe 10 years. This is not 10 years ago, but we have all the Gartner hype cycles with AI, and we are now actually driving this. So what happens if you apply AI? Maybe this. This is a more or less famous situation where a car needs to detect traffic lights, and there are these nice co-op flags, and there are traffic lights detected. So seems to be some failure. Maybe missing craftsmanship, I don't know. But there are other failures. We saw this request, please, DALL-E, generate me a salmon swimming down a river. And might be this is some social criticism here, I don't know, because of our food and what we eat, but I think it's just a failure. And even some problems with anatomy. Actually, AI, meanwhile, can do better, but we will still find such things, always. We will try to find the explanation why. So in the end, there's a lot of mysticism around. So we do things with AI and somehow it works, and we still, at least from research, do not understand why, but it's fine. It's speeding up time to market. And let's turn this mysticism into safety, trustworthiness. So for this, we need to understand about these AI technologies, this new cool thing. Looking into the past, we had mechanical solutions. When I was born and even before 1970, most of the products were mechanical. I'm even in some industries, defense, that tell me we can use the electronics, but we better do it in mechanics. Yeah, I understand. Then a lot of electronics came up. Things became smaller, became faster, more efficient. In software, they became even more changeable. And then AI came up. We had some, let me find the pointer. We had some hype, starting hype, an AI winter. And then now the curve is going up. So what is the cool thing about AI now? A lot of stuff. But for me, as a more formal guy, and I love reading PDFs, it is the possibility to implement implicit requirements. You show a little bit of a cat, and it does cats. Something like this. But of course, it is a new technology. And I call it a third kind. Of course, we have a lot of more technologies, but why third kind? If you remind yourself, the overview of the 26262 ISO is hardware, software, and now we have AI. And why is it a third kind of technology? Because it needs its own structured approach, V model, and it has its own fault models. And this is the core what I want to tell you today. So, but still, do we have the means to use AI safely? And I would say yes. Why? Because we have this risk-based approach, our reference safety lifecycle. You all know it. And what do we do there? We have a certain kind of traceability. We want to know what are we doing. So what is the problem with it? And what are we going to do about it? And then we go into the technology, system, hardware, software, and there's a missing box for AI. So, and this is the basic approach of the risk-based scheme. And the idea is to understand bottom up from the hierarchy of the system, what exactly are my faults? So I have a part in it. How can it fail? What is a fault and how can it fail? So in terms of resistor can break or shortcut. And this has a cause-consequence chain up to the next level of the hierarchy design and up to the car, up to the, we call it solution. So this is everything around the car, including the user. What we build is a black box. We will come to this. So, and what is the basic or the secret about functional safety here? The secret is to avoid systematic failures and to mitigate random failures. Okay, how do we translate this for AI? For hardware and software, we know it. Huh? We have to design it carefully according to the processes, and we have to mitigate random failures. This again is a little bit of voodoo for some of us, but it's possible. So let's check how we do this for AI. We need this structured approach. Overall, we have this life cycle. We need the fault model. We need to understand what exactly is the problem with AI. And we need a structured approach to evidentially build the AI, hopefully without or only with known failures. And then we can come up with safe or even trustworthy AI. So how are we going to do this? The first is to understand what exactly is the problem with AI? What are the fault models of this third kind of technology? Let's look into the development cycle very roughly. I sketched here for when you develop a neural network, 2 dimensions of inputs, or 2 dimensions, it's inputs and outputs. I don't have the hyperspace here in real, so but just let's regard these 2 dimensions. And what our neural network is doing is depicted by this circle. And this is a general concept, say, of a pedestrian or traffic light or whatever. So this is to be implemented. This is what we want. Then the developer comes in and thinks of certain characteristics of this element, and there's already a small creep because maybe he doesn't think of certain people, certain maybe wheelchairs, and he doesn't regard pedestrians or wheelchairs as pedestrians. Then there's some implicit concepts in the training data, in the data sets. Again, some creep. There can be optimally be learned, again, a creep in this from these data sets. But this is only if we have infinite time and calculating resources. So the actual concept that has been learned is again some shift. So there's this bow from what I wanted to do, what was intended, to the actual specified and to the implemented. And we see a lot of problems here. So we see things that have not been regarded as, in this case, traffic signs. There is research where from the data sets, some funny things have been learned. So here is a quite old publication, but if you have a neural network that detects firmly the traffic light, here it's a green one, but if you change this 1 pixel, everything switches to red. And in this case, even the other way around. And of course, you have these adversarial attacks and a lot of other stuff. So there's 2 categories. Systematic failures, yeah, you have to think of stuff and look at and put it into the data set, and some failures due to characteristics of the technology. You do not know actually what has been learned. So I do not want to bore you doing learning. All of you know this is not an exact thing. This is an approximation. We try to find some optimum. Never know if you really get it. The problem is it is not exact, and we don't know where exactly in the landscape we are. Another one, again, something like overfitting. If we try to get accurate, it's a problem. If we have low accuracy, we can have good generalization. And maybe if we have in this pictures from flower, bush, child, woman, man, skateboarder, cyclist, we have the wheelchair here, and we want to have higher accuracy. Might be that our polynomial typed classifier, it's kind of a polynomial, is swimming around and not hitting the wheelchair as true pedestrian. So we all know this. The consequence is that accuracy is no measure for functional safety, but we know all this. What might not be too much known is this hyperblob stuff. So what we at Fortis detected is that if in this hyperdimension, this blob is what a classifier, for example, represents. So this is pedestrian. Yeah. What we detected is that when you analyze this hyperblob, it has holes into the center, a lot of holes. So like this, you can go into it. You can go into this hyperblob and generate pictures that for us are not distinguishable, but for the neural network are clearly not a pedestrian, but for us it would be. So why is it so a problem? It is a problem because it enables something like black box attacks. Why? For attacks, attacking neural network, you want to find these funnels. And this is easily done, going on the surface, looking for a deep point in this hyperspace. And what we also found is that these funnels, not all, but if you take any neural network trained by any data set, does not need to be the same ones. They have similar funnels. So you grab some random networks from the internet, pre-trained, look for these funnels in 2 or 3 of them, and you are very probably hitting a funnel in the attacked black box network. So there are a lot of cool things with neural network. We do not understand everything. I do not just want to emphasize it. What we also don't understand is the very top level of neural networks. So how do we apply them? Just let's think of a network that distinguishes dogs and muffins. So it's an easy job. A nice dog, nice muffin. And so how would you say should the performance be of such a network? What is the human performance? What is your performance? Just take a quick look at these guys. Which are dogs, which are muffins? Quickly. So the problem is ethics in the end. It's engineering and ethics. So which performance do we need in autonomously driving cars? It is some uncertainty. It is not determinism. Neural networks, of course, are deterministic. So I just read an article, the first non-deterministic computers, but whatever we have, if it's NVIDIA chips or whatever, it is deterministic, Means same input, same output, even the same way how it is calculated. But there's some uncertainty. By the way, there are cool standards on uncertainty coming up. I will come to this. There's uncertainty because if you have a new pattern, you do not know if it's going to be detected, predicted as dog or muffin. There are other characteristics of neural networks. In the end, neural networks are some kind of automation. And funnily, we have this guy, Billings, very old paper talking about problems of automation. Read it. It's really cool. There are all the failures the aviation industry did. We can refrain from it. Anyways, so I was talking about failures, systematic and random failures. Systematic capability is something we can somehow measure or claim. The systematics of hardware and software. And what we do is to have culture, experts, quality assurance processes, design methods, proven designs, and so forth. And we can have it for hardware and software. And random, of course, is not in software. Either the fault is in or not. It doesn't change. But for hardware, we have this. We have message and thresholds for it, say failure fraction, or in automotive domain and the 262x2, it's even advanced single point fault matrix, latent fault matrix, and so forth. Sorry, I should have changed this. But it's the same for all standards, so just disregard. But what do we need to do for AI? Of course, AI is running on top of software, on top of hardware. There's some platform, fine. But do we have more? And yes, of course, we have more. We have, of course, a systematic thing we have to consider. We do this with a structured approach, V-model-like. And the other one is uncertainty-related failures. This is a new class. This is only for AI. We tried in the standardization to put it here, to put it here in terms of random failures in the AI, but this is not applicable. We might discuss afterwards with a beer in our hands. Anyways, we have to follow this structured process, consider these uncertainty-related stuff, and have our evidences for the safety argumentation. It's as easy as this. Unfortunately, quantifying uncertainty in neural networks is kind of research. So there are a lot of models, uncertainty models, many flavors, a good survey paper, you can read it, and George Bock's saying applies. So all models are wrong, some are useful. Depends on what you do. Anyways, industry needs something they can get hold of. And there was this Dean spec, which tried to give you some understanding it. There are further standards, and especially even in the 8800, there's some of it in it. And I just can invite you to join this working group at the DKE. We will do AI and functional safety, and especially currently care about uncertainty. There will be a new standard on uncertainty. This guy. It's tricky. However, there are approaches, details later, maybe with a beer. We need to look at the structured approach. The structured approach is like a V model. It's not a V model in its former sense. Why? We cannot trace requirements down to each neuron. This is not possible, at least not today. And as all these models grow, it won't get easier. But we can do a lot. We have more knowledge than nothing. We can prepare our data. We can check, is it really covering our operational design domain? Is the coverage and the density enough? There are metrics to calculate. Of course, it's a little bit of work. It's not like showing cats, it does cats. It's a little bit of traceable work. You have to care about your design. You implement your loss function, need to adhere to the trustworthiness or safety requirements. you have some verification. So in the end, did I get the most of my training data? I'm done with training. Am I done with the neural network design, or shall I pick another or add another layer? Is there some functional verification there? And there is some semantic verification. So this is very interesting. We will come to this. What are we doing there? This V model is in that standard, part 5. We are taking a lot of knowledge from, for example, research in KI-Absicherung. That was a big project which came up with, I don't know, almost, it's over 70 metrics, what you can do and how to apply, and which metric helps for what. And there are research projects like KI Wissen that came up with how, if I have formalized knowledge, how can I put it into a neural network? How am I ensuring that it's in there? And how do I get it out to compare it to the original formalized knowledge? There are things to do. So time is almost up, I think. I can't dig into the details here. But read the standard. Anyways, what we do is, in the end, we want to say, okay, our AI system, our automated car is safe to be used within a certain domain, operational design domain. We take this table, we saw it before, with the systematic, random, and uncertainty-related activities, have it as an evidence or an argumentation base, feed it in a hierarchy of maybe GSN, so goal structuring notation, safety argumentation, and then come up with no unacceptable effects on providing safe behavior. It's a little bit of future, but yeah, we are close to really do this. So neural networks are there somewhere in between hard and software. So Oscar, you are getting up. How many seconds? 3. Okay. So what we did here in this working group is that we started at the highest level, the solution level. We were clear that looking at the car is not enough. And we were setting up like these 6 parts, terms and concepts, management. You will be very familiar if you went through the 2632, except for that we have the solution level, which is the driving environment, user, and all stakeholders. Actually, this is a level where hazards happen. No hazards, only failures in the levels below. We can discuss this later. We took the safety lifecycle, included multi-aspects risk, trustworthiness, system of systems, system engineering, AI as a new technology, and came up with the standard. So if you use it, think of AI and safety, it's no more burden. And this standard helps you, if you implement it, to really have fun again, even with standards. Yeah, so after all, keep AI in the systems. Don't work around and do classical stuff. We can make it safe. It's a little bit of effort, but we can make it safe. Of course, one of the factors is the data. We still need the old good automation and systems engineering knowledge. The AI is not doing it for you. You need to identify which component is done with AI and which functionality. And we have to consider the fault models. What does it contribute, the component with AI, to the hazards? Thank you.
Okay, thank you very much, Henrik. Really impressive. So I've been reading it during my holidays. I just brought the standard with it and was reading it. It was really fun to read and very interesting, and I learned a lot. Most impressive for me were the long list of the methods and validation methods they are suggested from these AI research projects. Really fascinating. So I think I know 3 out of 30, so learned a lot. But let's see where there are questions, and I have already got one question here.
Thank you very much for the presentation. I have actually two questions. Is this a new standard that is actually taking a different approach than safety of intended functionality?
Then what?
The SOTIF,
SOTIF.
the safety of the intended functionality.
I'm not sure how many fans of the SOTIF standard are here in the room, so I do not want to say too much, but yes and no. So what SOTIF, what the 21448 does is it looks on the higher level. We call it solution level, but not consequently. We do it in a consequent way.
Yeah. So you mean that it was in deterministic way, the way that the SOTIF standard is handling the problem, but you are handling it in a systematic approach.
Yeah. Yeah.
Okay. Very good.
Good explanation. Thanks.
That's really great.
Yeah.
The other question is when you were talking in the, I think the last slide or the one before it about the argumentation. Yeah. You are using, for example, safety analysis in order to reach a good argumentation why you did not miss anything?
Yes,
what
also part of it. So this is very quick overview. There's a separate section in part 3, how to set up such a safety argumentation.
And what kind of safety analysis can be applied here?
I think we can apply, if you extend your mind a little bit, you can apply all the old approaches. So there is no more than top down and bottom up or inside out. So FEMA, FDA has up. There is no more, but you have to consider the fault modes. Actually, this is the basic thing I wanted to translate to you. We do not need new methods. We do not need a new safety life cycle. We can reuse everything, but we need to be aware of the fault modes of AI and have a clean systems engineering so that bottom up and top down, we can do the traceability of failures.
So like what is in ISO 26262, you have a keyword model failure modes, a keyword for failure modes. We need to have additional or new keywords in order to drive failure modes related to AI.
Yeah, so as long as you stay on the solution level or even on the system level, which is the car, it's agnostic to using AI or not.
Yes.
If it comes to the technology level, and this is hardware, software, AI, mechanics, chemical, biological, maybe in 10 years we are standing here talking about biological elements. There you have to look at exactly these. Right. There it differs.
But this standard is focusing on higher or lower level?
It's covering all.
Covering all. Okay. Thank you very much. Sorry for.
But yeah, wherever we have standards explaining it already well, we just refer to. So we do not repeat software or hardware parts. Yeah.
Thank you very much. Thank you.
Thank you.
Okay, so we have to take care of the time a little bit. One last question, and not 3, please, but only exactly one question, and then we move on. Is there one more question? Then, like, it is yours.
What is the relationship? First of all, thanks for the presentation. It was great. What is the relationship of this standard with 8800? That was not clear to me. How these are interconnected, because that would be interesting.
Yeah, Simon and I were on the same research group. Simon Burton.
Okay, good.
Well, that was short then. Henrik, thank you very much for the presentation again.
You're welcome. Thank you.
And then in terms of organizational topics, we are behind schedule, so we'll have to catch up. I will shorten my presentation, so it's not going to be excessively long. But we do have 2 more presentations after the break now. And in terms of the break, we have roughly 25 minutes, and then we guide everyone to come back because it also takes time to fill the room again. Then the final 2 presentations, and then the big dinner. So we should still aim roughly for 9 o'clock, 9:15, something like this, because there's like nice warm food being prepared, and we'd spoil it if we don't adhere to the schedule. But we'll make it work. So sorry, Oscar, you had some.
Yeah. Okay. Let's try to be here at latest 8, so in 20 minutes. So
yeah,
15 to 20 minutes. So you can go now. You can go to the basement again. Inside there's a Hof. There's something you can also be, and we'll have some small food around here as well. So drinks and things on the base floor, and be back here at half. Before we continue, just a short announcement. So today, maybe not so many people because there's a parallel event. 70,000 people are going to the Allianz Arena and watching the Champions League game Bayern gegen Dynamo Zagreb. But out upstairs, we will have a room and we'll be able to watch it as well. So who's interested in it? So I think it's here the better place to stay. So now let's continue. We are a bit behind the schedule, but I think we'll manage it quite in time. And I'm very happy and proud to have Fotios here with us. I heard in the beginning that we looked like brothers, so I cannot really judge this, but you might see it, and maybe we are like brothers in mind, because the work he's presenting about the tool chain analysis is also something that I really love very much, and I'm really proud to have you here on stage and give us a presentation on about your work and how to make the. I'm better in the meeting. So then, Fotios, come here, and the stage is yours.
Okay. Thank you very much, Oscar, for the invitation, and also thank you for providing the venue tonight, and to the org team.
The org team is really great. So it's Melina, it's Marcel, it's Alex, it's Michi, it's very many people helping here together. So this is very cool. Thank you.
Okay, thanks. Welcome, everybody. Good evening. Before I walk you through how we manage our tool chain at BMW in a safety relevant environment, just a few words about my person. I'm Fotios Nisiropoulos. I'm now 20 years at BMW. Started there in the head unit development department. With the E60, the 5 Series, and later on I was mainly in the IT department, caring for after sales and dealer management systems. And after about 10 years, I wanted to go back to the core product of BMW, which is the vehicle, and started there in the software logistics department, and was responsible for various car projects so that the right software comes in the right vehicle. And around about 2016, I got the first time in touch with the ISO 26262. I was there, Oh, okay, thanks. Just give me one more minute and then I have. Okay. And as I said, this was the first time I got in touch with the ISO and functional safety. And to be honest, I didn't really know what's going on there. And also, I'm also in the team. I don't like PDF documents and long regulations to read them. But unfortunately, there was no way out for this, and I had to do so. And in 2019, I then took over a position like the expert team lead for tool safety at EF, which encompasses the driving dynamics and also the autonomous driving at BMW. Currently, I'm phasing out from this function, and I'm going to take new challenges and new tasks. And Sama here in front will be my successor, or is already my successor. And she will carry on this great work which we have done so far. Okay, so functional safety, no uncharted territory for BMW. It is one of our core topics in our development, especially when we have a safety relevant development where we are developing brakes, steerings, autonomous functional functions, and but around about 2017, yeah, we had to face some new challenges. First of all, we were introducing and establishing a real agile working model. Why real? We had kind of agile working model, yeah, but it was a little bit typical for BMW, tailored for BMW. But this time, this was a real disruptive change. Yeah. On the other, the reason for this was that we wanted to conduct a substantial shift from buy to make software, especially for the ADAS function or in general for the driving assistance functions. And for this purpose also, we moved out from the FITS in the Knorrstraße, Unterschleißheim, to the autonomous driving campus, where we had completely new offices, which were tailored to the working model for feature teams, for product owners, etc., etc. And this also included another fact that we needed a lot of new people, developers, software developers, people who know how to develop embedded software. But the problem is you don't get them and they don't grow in the trees. Yeah. So especially if you need people which have experience in the automotive business. So there are several challenges, as you see here. But the other thing is you have to keep in touch with the rest of the company. Even if you develop in an agile model, you have interfaces, and your interface partners, they are waiting for certain artifacts that you give them. So you can't go there and tell them, well, the software for this ECU will come in about 2 or 3 sprints. They say, no, they will come to this sprint and to this sync point because we have to build cars in the factory. And in 2021, we had this deadline for the start of production of the iX series. As you see, here are a lot of challenges and topics that had to be managed until the SOP. But also this little guy hit us, which didn't make the tasks that we had even easier. So yeah, there was this saying used, we have a problem, but it was more, we need a plan how to cope with all these challenges. As I said, we had a completely new setup in our development department. And one piece in the ISO is, of course, the tool safety. Next to many other requirements deriving from the ISO. But the problem was you came there and there was a little bit like Wild West. Yeah, there were developers, feature teams, people who were too much involved in the working model and less in the product. And Milena and Reinhard and a few other people from my team, we ran around all departments and tried to find out which tools do we have at all. Yeah, what is our quantity structure at all, and what is the scope of all this? And during all this phase that we had for hunting and chasing for tools, we found that we have mainly 4 pillars which are really important if you have to do such a thing like tool classification and tool qualification. The first is, and it's as simple as it sounds, go out and systematically collect your tools. This means go from department to department, talk with the people, talk with the department managers. What tools are you using and what for? This is really a difficult task. It takes a lot of time, but there is no other way around. We had a few lists in Excel and so on. Yeah, there were tools and some people you can talk to, but they didn't feel responsible for the tools. They said, oh, I'm the user. Don't know what new version. I don't know. Use case. Well, I do this and that. Artifacts. Where do they go? Maybe somewhere. Yeah. Or I have no clue. Really difficult situation because time is running. Yeah. And you have to catch up as quick as possible. But we managed to get there an arrangement with all the departments and department managers so that we get a list and at least the quantity structure, which is really key and indispensable, so that you know what you are doing and how much time it will take. The second one is draw it. Literally draw boxes on a paper or in software in a system where you can see where the tools are, and not only boxes, plain boxes and some arrows with the artifact flow. Attribute them with, for example, which process step is involved in this, or which artifacts are involved. Who's responsible? Who owns this tool? Where can you go to and talk to if there's an update or a change in the use case for this tool? And identify the interfaces, not only the technical interfaces. This is quite easy often, but the organizational and processual interfaces. Because at this point, we talk about responsibility, and no one really wants to take responsibility because this is difficult. Yeah, some authorities may come up and ask you questions that you don't like, but it is really necessary to define this. And the best way to do this is to define a low threshold process and define roles for the people who are responsible for this. Yeah, make the process for collecting the tools, for change requests as easy as possible so that the people accept it and don't feel like there's a high burden to overcome until they get their tool legalized in that sense. And the last point is, and this is a point that you do practically is the last step, automate as far as possible and as soon as possible all the administrative tasks that you have to do. And the fifth one is stay away from Excel. Honestly, don't do such stuff like tracking lists or tool lists in Excel, because the point is not when it breaks, is not if it breaks, it will break. Yeah, at some point there are some collisions, data get lost, and so on. Excel is no database. Yeah. Okay, so let's go a little bit deeper. What we have done. We are administrating our tools in Codebeamer, which is basically a requirements management system. But the nice thing is you can set up lists there, which are traceable, which have a document history. You see what has changed, who has changed it, and it is a database. So in the beginning, we didn't know which attributes we need for a tool. Is it only the name? Is it the version or whatever? So we had a lot of attributes that you see here. Yeah, from what is the tool version? Who is the owner? Which is the use case? Which is in a simplified way because you just to have an idea what does this tool do? Yeah, what is the input? What is the output? Etc. 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 Today we know these are far too many. And we have to simplify this. Yeah, but at that point or at that stage, we were too uncertain. And so we decided, okay, let's collect as many data as possible and we sort them out later. For the use case, as I said, the detailed information is in the TCRs or in the TQRs because there's the analysis that is conducted by VALIDAS. There's all the documentation in, but for the first overview, this is good enough and yeah, helps us a lot because you have all functionalities there, so you can search for this. About the number of tools that we're currently using, we are at about 500 tools that are used there in our departments over 2 architectural generations. All in all, we checked nearly 1,000 tools. And the question then comes up, what is a tool? Yeah, the developers say, well, a tool is something that you buy and this and this and that. There comes another one and say, I'm using Excel because I have some CSV exports. Is this also a tool? Well, we say it depends what you do with this. But we had to exclude a few, for example, like IDEs, because we said, well, what's your development environment to write code is not really safety relevant, because the important stuff is then later when you compile your code, and there we have to ensure certain measures as if necessary. But all in all, we try to reduce or to exclude as much as possible, but make the people also aware of that scripts may also be tools. And this is some difficulty there, because they check into GitHub and they make another commit, and the version changes. And you have sometimes a very hard time to find out what has really changed. Is it only a bug fix that was made, or is it a new feature in this script? Okay, for the visualization, as I told you, what we have done was to take our data from CodeBeamer and exported this as an XML file, and took also data from the toolchain analyzer, which is a really nifty tool from VALIDAS, which helps you to model the tool chains and to keep track of potential errors, methods to mitigate these errors, and so on. And we fused these data, did a little bit magic with graphics libraries, so that we had a graphical representation of our tools. This is not really sexy, I admit this, but it helps to see where are my tools, in which process steps, and how is the artifact flow. And we had also the ability, if you click on one of these tools, you get to the CodeBeamer platform again, back into the list, and you see then the detailed information for this tool. This helped us really a lot, as we also had the possibility to define preset filters. If you search for something, for example, which tools have a TCL3, so you see then all tools with TCL3, what are the neighboring tools, and how is the artifact flow, so that you had a better idea where you have to go again and to reclassify or requalify your tools. Okay, for the process, as we had the first setup of all tools, the next step was, of course, how to deal with changes with these tools. Not only for version updates, what happens if new tools come? What happens if a tool is dismissed because it's not used anymore? Because in such a tool, there might be a mitigation. And if you dismiss this tool, then your mitigation is gone. Not very nice at the end, but you have to know about this. So we established a process which is really easy, where the tool owners, or we call them tool guards, can submit a ticket, say, hey, I have here a new tool. This is its name, this is its version, this is basically what it does. And so we have it at least on the radar, and can approach them and say, okay, let's talk about what is the use case for this? How do you use this? What are the artifacts? What are potential errors, so that we can conduct in the first step a classification? Okay, so this was now mainly how we manage our tool chain at EF. This is not, of course, not the end of the story. We have currently plans how to develop this further and to extend also this process and also this tooling that we have to other departments for the powertrain, for example, or the software factory that we have. Because as simple as it might look, other departments are really eager to copy this and to cooperate with us, because they know we have experience in this, and they also have the need to get away from Excel sheets where they have their lists and use cases listed, and have a common database together of all tools, so that we can also interchange the tools and say, okay, we have a tool here already classified or qualified. We have the same use case. Let's take this, and we're on the safe side. Okay.
Okay. Thank you very much. So this is 2 levels below the water. So, but it's very interesting what needs to be done there. So thank you very much. You can change the mic with Felix, or give it over. There's a question. Okay, well then I'll go here, and you have a question?
So I see really interesting work that has been done in the process here, but I was wondering why you didn't have some external like Celonis, that they are working in process optimization and also visualization. So has you thought about this during this time before developing the process inside in-house?
Do you mean the software development or this?
The process optimization for the tools and the visualization of it.
Well, yeah, as I told in the beginning, there were too many variables. There's a new working model, there's a new working organization, there's a new location, and there is the old BMW process, which was already known. And to bring up something or someone to bother the people again with process analysis and process definition might backfire, because then they get fed up. They have to develop a product, because the SOP, whatever may happen, this SOP will not change at that time. Yeah? And we have to concentrate on the product. These challenges that were listed here were only a few. There were many more cooperations with external partners, yeah, Stellantis, Intel, and so on and so on. Yeah, and to do this on a moving target is rather a really difficult task. And so we had to iteratively go step by step by step and develop all this.
Yeah, okay, thank you. I think the work was really centered around the tool chain and not so starting from the processes. So it's really starting from the tool chains where the most urgent comes from. Yeah. Is there a last quick question? Henrik?
Yeah, thanks for the talk. One question, how many tools were related to AI and related to AI verification?
At that time, none.
For the AI.
So what we have is, of course, tools which do some reprocessing and simulation and so on. But how many tools this as a number, I can't really say, because we have rather complex tool chains, and we also do some black boxing, because otherwise it gets too complex. But I would assume a few dozen tools which are related to AI.
Okay, so then thank you very much.
Thank you.
And now it's my pleasure to announce Felix Friedmann from NVIDIA, and he's product owner of the DriveOS platform, and which is also something below the water where the other programmers can just use it, and he'll give an overview about it, and he's giving the talk together with Ricardo Magnano, his safety expert at NVIDIA side. So he couldn't unfortunately come today here, but he prepared the slides together and will give some insights also from the safety perspective to it. Is it working? Yeah. Sounds good.
1, 2, 3, 4. Oh, thank you. Perfect.
Okay, so then Felix, now stage is yours, and okay, so then thanks for coming and presenting.
Thank you. We do have to finish the streaming session here. Unfortunately, I couldn't make that possible. So everyone who was on a stream, apologies for that, and thank you for staying online until this point in time. I hope you enjoyed the presentations so far. Again, unfortunately, we can't stream my session, but I hope you enjoyed it, and hope to see you soon. Bye, stream guys.